Alright everybody, today's lesson is on the counting principle, and we're going to jump right into a couple examples right away here. Example 1 says, how many ways can you get from point A to point C? So in this picture down below here, if all those black lines kind of represent roads, and I want to get from point A all the way to point C, alright, what we're really trying to find out is, well, how many different routes could we take? Alright, meaning, if I first have to go from A to B, what I could do is first take the top road, or we could take the bottom road. And then once you get to point B, then you have three more choices. You could take the top route from B to C. You could take the middle route from B to C. Or you could take the bottom route from B to C. So you have all these different options, and what really we want to do is count how many different ways that we're going to be able to do this. Okay? Well, there's not too many choices here. We could probably count it up just by, tracing over the lines. If I go the top to the top, that would be one route. If I go top to the middle, that's a second route. I could go top to the bottom, which is a third route. Okay, then if I, from A to B, choose the bottom, I'd go bottom to the top, so that's option number 4. Bottom to the middle is option 5. Bottom to the bottom would be option number 6. So there's going to be 6 different ways to get from point A to point C. The problem with doing it that way is it's nice and it's all fine when there's very low number of choices like there are here. But what if there's a lot of choices? We don't want to sit there and count this whole time. So there's a couple different ways you can do this. One is what we call a tree diagram. And tree diagrams are good because it helps let you see all the different options. All right, so that's what you would write down if you're doing a tree diagram. Is you'd write down, well, if I'm going from A to B, what would be my options? I could choose the top road, or we could choose the bottom road. Okay, and then basically off of both of these, then, if let's say that we chose the top road from A to B, well, then I have 3 different options to go with it from B to C. We could go the top again, we could go the middle, or we could go the bottom. And if we chose the bottom, I also have 3 options. We could go bottom to the top, bottom to the middle, or bottom to the bottom. And then what a tree diagram does is it lets you show all of the different outcomes. So we could have chose the top route to the top route. We could have chose the top to the middle, the top to the bottom. We could have chose the bottom, then the top. We could have chose the bottom and the middle, and finally the bottom and the bottom. And as you can see here, we have a total of 6 different outcomes. Okay? And again, what the tree diagram is, it lets you see what all those different outcomes are. That way, if I said, well, okay, if somebody randomly drove these roads from A to C, what's the probability that they chose the top road, and top road? Well, there's only one way to do that out of 6 total possibilities. All right, so tree diagrams are good that way. That's not what the counting principle is, though. Counting principle is super, super easy. Okay, for the counting principle, all you're simply going to do is, okay, my first choice is which road do I want to take from A to B, and how many choices are there? Well, there are 2 choices, because we could choose either the top or we could choose the bottom. There are 2 different choices. And then the next choice is going to be, okay, then from B to C, how many different choices do I have? Well, there are 3 of them. And what the counting principle says is, well, you find all your different choices or outcomes, and you're simply going to multiply them together, and look at that. We get 6 just by doing 2 times 3. This is what we call the counting principle when you're doing this simple multiplication. Okay, so that's what we're going to be doing today, is just this multiplying, writing down the different possibilities. Okay, example 2. It says you roll a blue number cube and a red number cube. All right, number cube is just a dice. All right, so we're rolling 2 dice. One is blue, one is red. We got a blue one, and we've got a red one. It says use the counting principle to find the number of different outcomes that are possible. Okay, so we're doing 2 things. So I'm just going to write this down here, that we have our blue cube, and we're going to roll that, and then we're going to roll our red cube. And what we need to write down here for counting principle is, well, how many different possibilities could you come up with? So just imagine if you were going to roll a dice, okay, well, how many different numbers are on it? If it's a standard dice, there's going to be 6 numbers on it. So when we roll the blue number cube, we have 6 different possible outcomes. We could roll a 1, a 2, a 3, a 4, a 5, or a 6. There are 6 different outcomes. I don't know which one's going to happen. I know it's going to be one of them. Okay, well then you go ahead and roll the red number cube. Again, if it's a standard dice, 6 sides, there are 6 possibilities for the red one, a 1, 2, 3, 4, 5, or 6. So what are all the different possibilities? Well, we're simply going to multiply those together. 6 times 6 give me 36 different outcomes. And we could go ahead and list them. We're not going to, but we could list them, starting with, if you roll 2 dice, you could get a 1 on both of them, all the way to a 6 on both of them. There are 36 numbers in between there. Okay, so there are 36 total. Okay, but that's what the counting principle is listing how many different results you could possibly get and then multiplying them together. All right, final example here. It says example 3. It says a combination lock has 40 numbers on its dial. You randomly choose 3 numbers on the lock. What is the probability that you choose the correct combination? So this would be like if you walk up to one of your lockers, a friend's locker, you don't know the combination, but you want to try to guess and get in that locker. Well, what's the probability that you're going to guess correctly on the first try? Okay. If you want to go ahead and try this on your own, go ahead and pause the video, see if you can come up with a number, and then you can come back and see the answer. Okay, so the way that I'm going to do it here is, since it says a combination lock, that we're going to have to choose 3 numbers, okay? Because that's what it takes to open a lock. So that means if I'm going to choose 3 numbers, I have my first number, I have to pick my second number, and I have to pick my third number, okay? Well, when I go up to the lock and I decide which number I want to guess for the first choice, well, there are 40 numbers on that dial. So I have 40 numbers to choose from for the first number, okay? And now here's where you really got to think. Well, on a lock, can you repeat numbers? Can you have a combination that's like 27, 3, 27? Can you repeat numbers like that? Well, yeah, you can, okay? So that means that when I make my second pick, all right, there are still 40 numbers that I can choose from, because I can choose the same number if I want. That's fine. Okay, and then my third choice, again, 40 numbers to choose from. So the counting principle says multiply these 3 things together. 40 times 40 times 40. And if you do that on your calculator, you're going to get that there are 64,000 different possible combinations. There are 64,000 possible combinations on that lock. Now, if all we wanted to know was how many different combinations there were, we'd be done. The answer would be 64,000. But it didn't say that. It said, what is the probability that you choose the correct combination? Well, out of those 64,000 possible combinations, all right, that it could be, there's only one correct combination that gets you in that locker. So what's the probability? The probability is going to be 1. Okay, there is one correct combination out of 64,000 different possible outcomes. 1 out of 64,000 would be the probability. Okay, so that's our lesson today on the counting principle.